Cool. All right. Thanks a lot, Milosh. Yeah. So I'm Aaron. I do tech art. So I do lots and lots of things. The actual skill set is super broad. Some technical artists are very specific. Some are a bit more generalist. So I tend to have a much more general knowledge base. One of those things that I have an understanding of is Niagara. So I understand that you're building some kind of first-person style shooter games at the moment. So I'm going to go through and show you how to kind of juice those up with some nice particle effects. I have to apologize in advance. I had COVID last week and I'm still recovering a little bit. So I have a bit of a blocked nose and a bit of a cough still. So I'll try and mute myself if I start coughing, but just keep that in mind. Luckily, it's not contagious over Zoom. So yeah, I'm going to share my screen. And I've got a little demo project that I'll take you through. If you would like to ask any questions at any point, feel free to throw them in the Q&A section. So I don't have the chat open anymore. I'll see if I can open that up. But yeah, if you could throw it into the Q&A section, then I will try and answer those as I go, just so that we can everyone can stay on top of things. If you want me to explain anything again, just again, feel free to ask, and we'll try and go through that stuff. Miloš as well has said that he will translate anything if you're not confident enough to write the question in English. So hopefully we'll get those answered as well. So I've taken the first-person shooter example project, and I've added a few little particle effects to it. So I've got this little kind of smoke fire effect. I've also added some effects to when you fire the gun. I'm not 100% sure what the quality of that's going to be like over Zoom. In fact, I should probably...
It's fine.
Is it okay?
Yeah, okay? Yeah, it's okay.
Oh, excellent. Cool.
Visible,
okay.
Yeah.
My internet connection here is not great at the moment, so I wasn't 100% sure. So yeah, we've got a little fire effect, an impact effect, and then I've added a trail to the ball. So I'm just going to take you through how some of those effects work. Again, if you've ever done Niagara work or particle work of this before, then none of this should be particularly new to you. But hopefully, if this is something that you're trying to work in for the first time, you'll learn something. And hopefully, if you have done it a fair bit before, you'll still learn something as well. So first off, I've created the systems here. Now, to cover how Niagara effects work, we actually have two Niagara systems or two particle effect systems in place. One is the old system, which is called Cascade. And then the new system, which is the one that we're going to be using today, that's called Niagara. So we're going to be focusing on Niagara today. If you end up creating a Cascade particle effect, then that is the old system, and you ideally want to switch over to the new system. So you'll see here we've got particle system. We can ignore that because that's the old way. We need to go down to the effects tab, and we need to go down to Niagara. Now you'll see a bunch of extra options here, and this might seem a little bit overwhelming. The easiest thing that you can do for now is to just focus on system, Niagara system. These are the actors that you place within the world, right? So when we create a new system, it'll ask us to pick, I'll just move this over to the center of the screen. It'll ask us to pick from either prefabbed or pre-built ones, or some examples, or copy existing ones. I'm going to create just an empty system and press finish. And I'm not even going to name it because we're going to delete this thing in a minute. So these are the things that you could drop in the world, right? At the moment, they don't have any contents to them. So you can kind of see here, we have our base new Niagara system. And this is the kind of the global property setup for this particular system, right? So the way that you can think of it is at the top level, you have systems. So in this case, we have our system. And then inside that system, there are a number of emitters, and emitters spawn particles, right? So if we right click in this graph, we can add emitter here, and we can add a bunch of base ones. So I'm going to add a fountain, and I'm just going to press save. And now when I drop this in, we suddenly have this fountain particle effect being spawned into the world, right? So we have that particle system in place, and we have our emitter inside that. And if we want, we could add more emitters inside here, right? So let's add an omnidirectional burst as well to this. And then just drop this in as well. So now you can see that as well as that fountain effect, we also have that burst of particles coming in at the start. So we can have multiple emitters inside a single system. And what's really nice about this is that we can set variables like float parameters or vector parameters at the system level. And those variables could be shared across every emitter, right? So this is how we go about creating global variables for these particular systems. So if we want to do that, we can define a value at the start. Let's say we want to set a new or existing parameter directly, and we want that to be a color. And we want that color to be a nice hot pink. And we can then name that parameter as well. So at the moment, it's I'm just going to full screen this so you can see we've got new linear color. We're just going to call this shared color. Okay, so we have shared color here. And then we can start referencing that, right? Because inside our emitter, we have what's called modules. And these modules, you can kind of see each of these here happen at different stages. So we have our emitter level, which again is a global variable, but for that single emitter. So we can set variables for each of these emitters that will be shared across all the particles spawned by each of these. And then we have the particle level as well. So particle spawn happens right when that particle is created and comes into being. And then we have particle update, which happens every single frame on that particle effect. So that's space is reserved for things that change over time, things that are going to update continually throughout the particle's life, right? So in this instance, in particle spawn, we have sphere location and add velocity and cone, right? So all that's saying is it's basically going, my start location for my particle is going to be within this sphere size. So in this instance, a sphere radius of 8. And then I'm going to add an initial velocity and cone, which is going to be between 500 and 850 with a cone angle of 20 and with my cone axis of 1, right? So that's pointing upwards. And then once I've done that, I can go to update. So I have particle state, and that tracks the life of the particle. A gravity force will apply a constant force downwards. Same with gravity, with drag as well. That will apply a constant drag to the particle system. And then we have a scale color, and then we have solve forces and velocity, right? So, and these happen in sequence. So one of the things that's important to remember with this is that you may inadvertently overwrite a value that you're setting first in your particle update or particle spawn that you then override. So if, for example, I were to put sphere location down underneath solve forces and velocity, this would negate any of the stuff that I've done in here, because it goes, okay, well, I need to update my particle state. So how much longer is my particle? I need to apply a bit of gravitational force downwards. I need to apply a bit of drag, so it's going to go down a little bit less. I'm going to accumulate that and solve that with my solve forces and velocity. And then I'm going to set the particle position to be within this circle, right? So you can see how that would just completely override that value. So really important to keep in mind. Anyway, so we've got this shared value and we want to set that, right? So inside my initialized particle, which is kind of a standard node that we've created that will set up a few basic parameters on your particle effect, we have a thing called color mode, and we have direct set. We can ignore this and unset it or set it between a random range, but we have direct set here. And at the moment we have a value, right? So I could set this to be blue, and then I could set that other particle effect if I wanted it to be something like green, right? But if I want this to have a shared color between the two, that's a bit trickier, right? So I can either just manually do it, and that's fine. You know, I could copy the hex linear or whatever and paste that into here. But what if I wanted to change that color value over time and I wanted that to be shared across both of them? That gets a little bit trickier then. So what we can do inside Niagara is we can actually bind variables to data. So in this instance, we have color, and this is a color variable type. And if we type in my variable that I set at the start, shared color, you can see that that comes up as an option. So I can just tie that directly to it. And now you can see that that fountain is now that pink color that I set before. And if I set that to the other one, you can set that as well. Right, so now we have two variables that are both sharing the same, or two emitters, sorry, that are sharing the same system level particle, right? And we could do this at the emitter level as well. So if we wanted to have some shared data that all the particles could access, then we could set that at the emitter level. And then that would be held just inside that emitter. So it's very, very regimented and hierarchical in this way. So we have our system, we have our emitter, we have our particles, and all of those can access data above them. So the particle can access the emitter, can access the system, the emitter can access the system, but they don't work the other way around, right? So generally particle data can't set upwards, but it can read. So with this system in place, we've got our particle system. We could even go in and we could change this color, right? So we can set a new or existing parameter directly, and that's inside the system update. So this is happening over time. And we can say that we're going to set shared color, right? And in this instance, I want to lerp this, lerp linear color, and my lerp factor, I want to do over a period of time. So if I type in time, we can get a few different options. So we can have real time. We probably don't want that. We probably want to normalize time. So if we type in system age, normalized, that's what we want, right? So that's basically going to give us a normalized, so a value between 0 and 1 of the age of this particular system. And that means that it's going to fade from one color to another over the course of that system's life. Now, that can get quite difficult to track. So you can kind of see how that started to get darker because we are needing to manually set what that's going to be. So I'm just going to make these colors a little bit more obvious. So it goes from purple to green. And we want to sort out our system's lifetime as well. So inside our system state, you can see that our system is about 5 seconds long. Or the loop duration is 5 seconds long. If we set that to be shorter, you can see that that color starts changing a little bit smaller at once. And that's how you kind of start creating and sharing those variables. So let's take a look at some of the spawned variables that we're using inside our system. And we're just going to delete that pink and green mess. And we have a question. So how would we go about create a particle system that bursts once and gets deleted afterwards? Do we shorten the particle's lifespan? So this is a great one and actually segues me perfectly onto the systems that I was about to talk about anyway. So that's a great question. So we have these particles at the moment. So we have one that fires right when you fire the gun, you get that kind of like spray, and then you get one that kind of pings off the wall. So you get that little one. Now, these are one-shot particle effects, right? So exactly what you're talking about. You spawn them, they do their job, and then they get deleted, right? Now, the way that we set these up, and let's look at the impact one, just so we can see it. So we've got this little impact, really, really simple. I've tried to keep these as simple as possible for this. So what we do inside our system state is that inside our loop behavior, we just need to set this to once, right? So that's the easiest way of doing this. We can also set it to multiple as well. So that means that this thing's going to fire X number of times. In this case, we could say 5. So that way it's going to be like 1, 2, 3, 4, 5, and then it's going to die. Or we can just set it to once, right? And that's just going to be the once in that lifetime. So for this particular particle effect, the loop duration is 1 second. So that means that this system will live for 1 second and then it will automatically die, right? And we have a few different inactive responses. So we can kill the system and emitters die immediately, or we can complete, which basically spawns, lets the emitters finish, and then kills it, right? So once you set this to the loop behavior of once, then it will automatically delete itself once it's been spawned into the world and it's done its job. So inside our first person character, I can show you how this is spawned. Now, again, we have two systems in place. So if we type in spawn particle, we actually get emitter, and we want to avoid emitter because that's the old way of doing it. What we need to do is make sure we spawn systems. So systems are what we're using. Make sure that you are using systems rather than emitters. And that should do all you need. And you can see here that we have an auto destroy tick box inside this on our spawn system. So as long as we've ticked this, and as long as the actual system itself has a finite amount of time to live, in that it's only got a set amount of time inside the system, then it should be absolutely fine. It should automatically kill itself, and then you can just throw away and forget them. So that's what I'm doing here with these, right? So every time I press that left mouse button, I'm getting a particle system fires off, and it goes, and then we have more. I can just keep spawning them. Right, so that's the basics of your loop and your setup. So now we'll just go into a little bit of how these ones were actually made. So again, the fire is really simple, right? It's just a very simple one shot. And this is generally how I build up particle systems, right? So I start off and just get the movement going right. That's kind of my first step. And then I worry about the actual texturing, the material processes, and the variation inside there afterwards. So when I'm first building these particles, I'm often doing them as these kind of like white boxed, kind of particle effects setups, right? So just getting that movement and that feel working quickly just helps you, kind of work quickly and iterate on those systems. So generally, the way that I build my systems at first is I will create empty systems. So that's the right-click effects, Niagara system, and then empty. And then what I will do is I will start populating these with empty emitters. So add emitter, and then we actually have a pre-built empty emitter type, right, that you can add. And it's got literally it's got one thing in it, or two things in it. So the initialized particle and the particle state, right? So this is the kind of the bare minimum that you need. It doesn't actually even spawn anything when you first drop it in. So if we disable all of these, you can see it just doesn't do anything. So when we spawn into the world, we need to decide what we're going to spawn. So in this instance, we want to do a sprite renderer, but we could do a mesh or a light, or we could do a ribbon. And then we need to decide how we're going to spawn it, right? So we can do generally a spawn rate, which is going to continually spawn particles at a certain rate over time. And then we also have a spawn burst as well. So we need to do that in emitter update. Right, so we have spawn burst instantaneous. And what that will do is it will just immediately spawn X number of particles, so however many we put into here, into the world. So that's going to spawn those in. So we could set that to 30. And you can see that the only thing that changes is that this particle gets brighter. And that's just because all 30 of those particles are now laid up on top of one another. So once we have these in place, then we can start. So we've spawned our particles, and now we can start doing stuff with them, right? So we can initialize, and this will allow us to directly set variables. So we could set the sprite size. Now we've got a few options here. We could do uniform or random. I'm going to go for random uniform and just let that pick, just a couple of sizes between it. Now, again, hard to see because these particles are all overlaid on top of one another. But as soon as we start moving these particles, so let's add a force. And in fact, let's just add a gravity force because that's going to be nice and easy. This is great, actually. Right. So when we first start adding things, what you might see is you might start to get an error, right? And this is an unmet dependency. Now, these are really handy because basically Niagara is really, really, really quite complex, but we want it to be reasonably easy for people use a lot of the time, right? So what we do is we don't presume that you want something that's dependent on another module. So in this instance, gravity is dependent on solid forces and velocity, right? Because all force and velocity, modules that are created in here, so anything that basically will apply a force or apply a velocity, uses the solid forces and velocity module in order to correctly accumulate all of that data over time, right? Because you don't want to just apply those variables individually, you want to accumulate them as a whole and then apply them. But we also acknowledge that you may know what you're doing and may have something else in mind for this particular system, right? So you may want to handle the gravity force yourself in some other way. And that's why we always put in this error rather than just solving it for you immediately, because you may want to do something else in that sense. So we have a nice little warning here: dismiss the issue without fixing. In brackets, I know what I'm doing, which I love. That it's got that little warning in there. And then we have or the option add new dependency module, solve forces and velocity. So if we just press fix issue, it will automatically add that module to it, and then that will just start working for our system, right? So nice and easy. Now at the moment they're all falling at the same time. So what we need to do is we either need to give each of these their own gravitational force, or we need to give them their own individual mass, right? Because a mass will generally give us that value. So we're going to set this to random, and then I'm just going to let this play, and I'm going to really ramp up that value. Right, there we go. And then I'm also going to add a initial force as well. So in this instance, I'm just going to add a cone force, because that's a nice quick way of doing it. And I'm going to set that to something like 800, and I'm going to set that into the Z, right? So this is going to basically create an initial force. Now you can see all of these individual particles have got that. So that's gone into particle spawn. So that's an initial force that gets added. So it wouldn't actually do anything without the solid forces and velocity, but then the gravitational force is a constant force that's being applied. And we've got another question. How would you make a particle system which generally triggers once per click, but prolongs the loop duration if we hold the click down for a couple of seconds, something like a muzzle flash effect? Right, okay, yeah, so this is a good one. So what you generally want to do at that point, if you want this to be a held down effect or something that you may even change over time, sorry, little cough there. The way that you would go about doing that is that you actually just loop the whole system, right? So for this one, for example, if we've got this in place, these are all currently set to fire once, right? So if we just play the effect, you can kind of see that system playing there. So we have the little kind of force, and it comes out like that. What we actually need to do is, rather than have that set to once, we actually set that to infinite and just let that fire over and over and over again, right? So and we then need to also time that to our particle state, right? So if we do something like 0.2, we'll see how that looks. Right, so now we have this system that's just, kind of constantly firing. And what we do is, once we have that system in place, so there's our particle state there, what we need to do is we just, rather than spawn a system at that point, we just need to manually add it as a component. And we can still spawn this. I'm just going to add it in just to keep it as simple as possible. I'm just going to put that in underneath the gun, call that fire. Like so. And then when we fire, what we want to do is we just want to activate this. Right, so we fire it and we set it to new active tick. And when we don't want it anymore, so let's just say when we release the fire button, we just set it to not active anymore. So you can see that now I've got that system in place. Haven't tied it to the particle correctly, but we've got that now firing all the time until we let go. And that's probably the easiest way of getting that kind of repeated value. And what we can also do is, because we can send data to Niagara, we can actually update this variable over time. So let's say you've got like something like a minigun and you want it to start off quite slow and then kind of ramp up. You could feed that variable, that speed variable, into Niagara and have that control how rapidly it fires those particles. Right, can Niagara particles be added / modified through C++, or are they exclusively done in Blueprint? So they can be, you can spawn them in C++, that's absolutely fine. Like because Blueprint is just an extension of C++, right? So anything that you can do in Blueprint, you can do in C++. So yes, you could definitely spawn them and modify them, but generally it is much easier and quicker to just do it inside Blueprint. Anything that is event driven or is visually driven is often much quicker to do inside just a simple Niagara, inside a simple Blueprint, just because they're quicker to work and they're quicker to compile, and you won't get any real difference in terms of speed or anything like that. Generally, you only really need to do C++ for anything that, one, you can't do in Blueprint, or two, is going to run on something like the event tick, or just needs to be optimized in a way that you just can't do inside Blueprint. So anything that needs to be asynchronous or something like that. But yeah, otherwise, Blueprints are absolutely fine, but you can still absolutely do it inside C++. Next question. How would we make a particle system which generally triggers once per click but prolongs the loop duration if we are... Oh, no, we've done that one. Sorry. Okay, yeah. I can just click answer live, right? Yeah. Okay, cool. Keep the questions coming. If you've got them, feel free to ask them. It's always good. It helps steers the talk. So anyway, we can do it that way. That's absolutely fine. I'm just going to get rid of this for now because we don't actually need to do it that way. Right, and then we've got a number of different ways of actually attaching this, right? So once we've kind of got that speed working, we've got the lifetime working. I've got a little bit of complexity in here. So I've got kind of two effects. I've got kind of one kind of big scatter, and then I've got a kind of a smaller but kind of more controlled scatter shot that kind of comes in. And we can, again, once we've got these general kind of like placement right, then we can go in and we can start adding adding to the material, right, and adding to the color and stuff. But generally, I just want to get this kind of like white box particle in first. Then what I've also done is I've added just a little bit of an offshoot, right? So to kind of fake that the shell being ejected from the side of the gun. And again, we can kind of position this a little bit better. I've just put it in, and I've actually added a collision value to that as well. So again, that's just another module. You can build your own modules. We have a ton of modules built in. So generally, all you'll need to do when you're building your particle effects is you just add the modules that you need and you just let them go. Got another question. So can we use Niagara if we wanted to make something like bullet tracers? And can this be tied with actual physical projectiles? Okay, so the actual bullet that we've got in this, right, the big yellow ball, I still seem to have that particle system in my scene. Let's get rid of that because we do not want that in the way. So this is an actual physical object, right? So it's actually is interacting. I haven't set the particle to be once still. Whoops, there we go. Okay, that should do. It should stop the particle explosion. There we go. Okay, we're back to normal. So these are kind of a physical object that's hitting, and these are having physical impacts as well. When these bullets hit something, right, they will generate a hit event as long as you've got the event set up. And that's where you can spawn another particle system, right? So that's generally what I'm doing here. So when we hit the wall, that generates a hit event, and then that will cause a particle to spawn. So inside the ball, I'm basically just doing a collision check. So is my velocity more than 500, right? And that stops it from just spawning really, really repeatedly, and make sure it's reserved for just those hits. And as long as it's more than 500, then we just spawn the system at the hit location, and then I use the hit normal to angle that particle at the right point in space as well. So you can see that that's kind of generating that hit point. So if you want to do your bullets as physical objects that are actually have a velocity and a physical force, that's absolutely fine. You just have them as blueprint, and then you can just have those have a Niagara system attached to them, which again is how I've done that ribbon trail for this particular bullet. And then you can have them spawn particles when stuff happens, like when they hit something. For things like traces instead, you're not actually spawning anything when you trace, right? So you'll just do a line trace from channel from the point of the bullet. So, you just go line trace by channel, right? And that would just come out from the bullet point. And then that hit result, you would then just use as the same thing as we're doing with our bullet, right? So we got our hit location, our hit normal, and we can just spawn a system at that point. So we've got our location, our normal, so make rot from X, we'll do that, right? And that's how you do your trace, right? So if you get a successful trace, so we need to branch from that, make sure it's actually successful. And then we also probably need to check the actor as well, right? So make sure that what we're hitting is actually going to be something that we want to hit, or again, we can change the type of thing that we're hitting based on the actor that we hit. So we could do a check on our hit actor or our physics material, and so on. So this will basically do that check. Yes, it's hit something. We could do some further checking on that to see how we want to do that. And then we can spawn that impact particle with that right thing. And again, we've got auto destroy on there, so it'll automatically kill that particle once it's done. So that's how you do traces and general physical projectiles. They're very, very similar. You just have, kind of the two key objects there. The only other thing I'd say with traces is that you can actually spawn from the point of the gun to the hit location. And that's quite nice if you want to do kind of like a beam effect, even if it's still a trace. So you can take in those two locations, and that's pretty easy to do as well. So when you have your spawn system, you can set any parameter to this, right? So if we set a vector parameter, oh, sorry, we can name that. So we could do like target location. And then we could get that hit point, right? So I'm just going to promote that to a variable, just because it's arbitrary, right? And then once we've got that, we've actually output that variable to the system. So on our fire, we can grab any data from that just by setting it under a user parameter. So as long as there's a correct or similar vector with the same name, which was brain target location, I always just paste these just to avoid getting anything wrong. So as long as we've got a target location, we could do anything with that, right? So basically that's going to feed in that data, and then we can set it any way we want. So we could set this to be a target location, an attraction force. We could set, if we had a beam, so if we do like a dynamic beam or something like that, generally the beam will have a start and an end that you can set on here. So we could set an absolute beam end. We could set this to be the target location for that, and that would set that beam to basically always go to that location. So that's how you could do some extra work on top of that as well. Next question, is there a way to manually place particles, for example, to make a letter before they blast away? Yes, there absolutely is. So I actually did this. Oh, damn it. I don't know if I've put the the particle in. Let me load up another project. That shouldn't take too long to do. So where is it? Should be Niagara demo. So yeah, there's a few different ways to do manually placed particles. So as I said before, you could set vector parameters, right? So that allows you to set exact positions. So you can absolutely do that on yours. You could output the positional data for each of these ones. So for letters, for example, if you wanted to have it say like blam and do kind of like quite a cartoony effect, you can have a vector parameter for the position. So B, L, A, and M. And you spawn those as particles for each one and their positions for each one. And then when you've got that, you also output the letter that it needs to be as well. And you would probably do that as a text line. So you'd have all of the letters that you'd need, A to Z or whatever. And then you would basically have it so that you'd have a float value that would select what that letter needs to be. So like a flipbook, for example. So I've got a flipbook example here, right? So for this one, this is my flipbook for smoke. So it just randomly selects it. You could very easily switch this out to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, right? And then you basically just select that sprite based on the number that you output to the thing. So you could set that for each position, and then you've got all of your letters in there. So then it's just a case of positioning them, which again, you just output as a vector. Okay, I think those are both answered. The other way of doing it as well, I think I should have my card deck in here. I may have broken this earlier, but worth checking. Yes, I have broken it. God dang it. Anyway, okay, so I'll just show you the basics on here, right? So all I'm doing with this is I actually have a skeleton set. So this one here. And all I need from this data is the bone data, right? So basically I have the bones for each individual card. And then from that card, I can basically just spawn whatever I want on each one. So I spawn a particle effect card at each point, and then that one goes through and completes, right? So that's one other way of having kind of set positions and outputting that data. You can technically do arrays as well, but at the moment it's a little bit finicky. So I would stick to either skeletal data and reading bones, or I would use the kind of just the manual placement that you set inside a variable. Right, so we've got our spawn working, right, for our particles. I'll just quickly show you the ribbon as well, because that one's quite a simple one. How much time have I got left? A couple of minutes. Still good. We have our ball trail. So for this one, you can see really small. Sometimes particles are quite difficult to read if you're setting them to kind of like mainly have its movement derived inside the player or the object, right? So with this one, you can't really see anything. And that's because you're kind of reliant on actually seeing it scaling over the size of the particle. So you can kind of see that one there. But the way this one works is, again, you just spawn a ribbon renderer. And these are really much easier to see if you start out as a sprite render. So if you attach the sprite to them, you can see how those sprites are spawning. And that's how you build your ribbon, right? So really, ribbons can be quite complex to visualize in your head. So the best way to do it is to just spawn those as particles to start with, and just make sure you get that trail right and spawning in the right order. And then once you've got that trail correct, like you can see here, that will make it much easier. Then all you need to do is add a ribbon renderer. And if you put initialize ribbon in as well, you'll get that nice trail control. And that's all I'm doing here, right? So I'm literally just spawning particles at events, right? Cool. Another question. Niagara has collision event, right? So we can do rain ripples. Yes. So events are a very good question on that one. So the way that you handle events, and we could probably do this inside. I've just broken this up. Like, yeah, we want to do rip and trail. If we do inside the fire system, we have a number of different events that we can do. So if we just type in event into the particle update, so that has to be in particle update, you get 3 different event controls. So you have collision, death, and location. So you're probably looking for a collision event, though it could also equally be a death event if you kill the rain particle as it hits. So you can generate your collision event. And that probably needs to come in before solve forces and velocity, I would guess. Or does it need to come in before collision? Nope, there we go. Let's just see if that does it. What are you worrying about? I'm just going to ignore that. That's probably fine. It's probably because there's nothing handling it at the moment. And then we need something to receive that event, right? So if we do another empty particle, we then have a thing called event handlers. So you add your event handler, and this is where it gets a little bit, can get a little bit confusing. We have our system here, collision event. Don't know why that's creating a location event. I'll just switch to a location event just for now, just to show it a little bit better. Does not want. Okay. Could be because it requires persistent IDs. And there we go, that's the problem. Needs persistent IDs on it to spawn correctly. Not quite sure why that wasn't telling me that, but anyway. So we add an event handler, and then once we've got that and it's compiling correctly, we add the event that we get. So you can see that this is the name of the emitter, so empty O2. And we have our location event, which we could put inside here. I will just try and switch that back over to the collision event, just so that we are staying on the question correctly. And then we can basically assign that collision event inside here. Now, we don't necessarily want to spawn any particles inside our emitter update. We generally want to spawn those inside our handler. Right, so we're just going to tell that to spawn 1. And then we also need a receive collision event. So that's where this can get a little bit confusing, right? Because you think, oh, I just need to take my event handler properties and mark the event. That's not actually the case for this one. You need to add the event handler, and then you need to tell it to receive those particular events. Once you've got that, you'll see that you get a number of things that you can choose to apply or to output, and then you can spawn your thing from that. So if you want to do really complex rain like that, you can have your rain droplet fall. Once it collides, it spawns the collision event and then will ideally kill itself. And then you have that rain droplet can then spawn and it can go up from there. So that's all done with event handlers. But yeah, the key thing to remember with those is that you need to add your event handler properties, and then you need to receive your event type as well in order for that to work properly. Okay. Right, so I guess the last thing I just want to talk about is the actual material interaction. So the material interaction is super, super important for getting nice looking particle effects and systems. It's the kind of the core underneath all of this stuff. Really, all you're doing with your emitter and your particles is just spawning sprites and meshes, right? So the actual thing that will make this a lot of the time is actually inside the material itself. So I've got a smoke effect particle here, and I go into this in a little bit more detail in some of the videos that I've done on creating Niagara particle effects. This one has a little bit of kind of normal map trickery and also some warp trickery in it as well to make it look a little bit more convincing. So you can see it's got quite a lot of curling and kind of fake, kind of swirl information in there that's not actually there. And this is quite difficult to do. So, if you wanted to do this in kind of like a semi-properly kind of way, you'd have to add a simulation stages event, right, where you actually spawn this on a big card and then you have that distort and warp over time. This way is much cheaper to do, where you actually just warp that data, and almost all of this is being handled inside the material. So we've got a few tricks to make this look good. The first is a depth fade. Depth fade is really nice because it will hide any clipping that you might be having inside your particle effect. So if I move this right into the corner, and then I'm going to turn off depth fade just so you can see it. So you can see that these particles are having this nice kind of blend. They're not actually clipping into the wall. They're kind of fading out around it. So if I disable that and we just let that compile, I'm just going to take a few seconds. Give it a sec. There we go. Now you can see these really harsh lines and these harsh edges, right? And that's because the sprite is actually intersecting with that wall. So you can see that those kind of like those lines are appearing there. Depth fade will get rid of all of that, right? Because it actually gets the depth of the scene that you're going through. And when that gets close to what your sprite actually is, then it starts fading those out, right? So you can see just by adding that depth fade in, you get a much nicer interaction there. So the first step on that is that depth fade. That's going to add a little bit more to it. And then what we're also doing as well is we're doing a little bit of warping of the actual particle itself. Now I've added in a float parameter here so we can kind of control the strength of this manually. But if you see there, as I kind of like scale this value up and down, I'll just do it. You can see it gets more wispy, it gets more kind of like broken, and it gets that kind of a little bit more almost snake-like movement as it kind of goes through. And that's all that warp value is doing. So for this, what I've got here is I have a noise parameter, which is a three-dimensional noise. And as that particle passes through, it's going to warp, but it warps based on the strength of this dynamic parameter. So inside here, I've got a warp value, which is called a dynamic parameter, and I can set these dynamic parameters directly inside my particle system. So for this one, I actually blend it between 0 and it's actually really subtle. It's just about gets to 0.1 nearly on here. So it basically blends between 0 and 0.1 over the lifetime of the particle. And all that's doing is it's basically blending it from the no warp texture that we've got before to the increased warp value above. So if I increase this value here, you can kind of see that that smoke value gets even stronger on there as it kind of goes up. Right, but the actual system itself is really simple. This one was made a little while ago, so I could actually replace a lot of these with just the initialize sprite module instead. So anyway, we've got basically just kind of setting some initial variables on the object, and then we set it manually, right? So the only other thing I'd say with this one that's a little bit clever about it is that it's got a sprite sheet. So we basically iterate through this, and that gives you a little bit more turbulence, a little bit more change over time for this particular effect. Right, and I have managed to finish a little bit early. So I don't know if you have any more questions, feel free to ask them. Otherwise, we can wrap up the session a little bit earlier.
We don't have any questions. I guess we can wrap it up, huh? Oh, there is one.
Is there a limit for a size of particle? Technically, no. I mean, you can make a particle as big as you like, but the thing that you'll be affecting with that is the bounds. for that particle. So, you know, kind of the bounds that you apply to your particle system will generally define whether it's rendered or not. So if you make your particle really, really big, then that will increase the bounds and the size of that particular particle that's going to render by. You will also almost definitely run into some issues with it, depending on how you align that sprite, right? So generally your sprite will be camera aligned, which means that it will rotate to always meet your camera. But that kind of can mean that you'll run into weird intersections as that sprite moves around. So yeah, no, technically no, but you'd probably start seeing some weird issues if you did, but you can make particles very, very large. How demanding is Niagara? How much can we use it without impacting performance too much? So that's a really great one. Unfortunately, it's a little bit kind of how long is a piece of string question. The Niagara can be really, really expensive. And it depends on how many particles you're spawning, whether you're spawning on the CPU or the GPU.